Why can homing pigeons deliver messages without getting lost? Why do pigeons have such a good ability to recognize home? It's because there are magnetic cells in their heads, which acts as a compass. They can use the geomagnetism to find their home. If a magnet is tied to the head of a pigeon, the pigeon will get lost. If pigeons fly over a radio transmitter, the powerful electromagnetic wave interference, it will also make them lose their way. What is a magnetic field? What are the properties of magnetic fields? Next, let's learn about the magnetic field together. First, there is a magnetic field around a magnet. Second, there is a magnetic field around a current. In 1820, the Danish physicist Hans Christian Ørsted first discovered the magnetic effect of current. That current can produce a magnetic field. He found that when a current-carrying wire approached a compass, the compass needle would deflect. After the power is turned off, the compass returns to its original state. This shows that current can produce magnetism. He was the first to discover the relationship between electricity and magnetism. We can conclude that the source of magnetic field is magnet current. Third, the basic properties of magnetic fields. Magnetic interaction between magnets does not require direct contact. We know that the interaction between charges occurs through invisible and intangible electric fields. In fact, between magnets and magnets, between currents and currents, between current and magnet is through invisible, and magnetic fields interact through invisible and intangible magnetic fields like the electric field. Magnetic field is also an objective existence. It does not depend on our senses. Some people may ask, since it is invisible and intangible, how do we know its existence? This requires us to use the properties that the magnetic field shows extensively to infer its existence. Magnetic field has such a property. It exerts a force on a magnet or current-carrying wire. The magnetic field has an effect of magnetic field force on the magnet or current inside it. The two ends of a magnet are the strongest in magnetism. The pole pointing to the south is called the south pole, denoted by S, and the pole pointing to the north is called the north pole and is represented by N. Second leg pulses repel each other, and the pulses of different natures attract each other. This mutual force between magnetic pulses is called magnetism. Third, the north and south poles of a magnet depend on each other, cannot exist alone. The direction of the magnetic field. Physics stipulates that at any point in the magnetic field, the direction of the north pole of a small magnet is the direction of the magnetic field at that point. Second, magnetic induction line. Magnetic induction line is also called magnetic lines of force. In 1831, Faraday used iron powder to experiment, vividly proved the existence of magnetic lines. He pointed out that these magnetic lines of force are not geometric, but an objective existence with physical properties. This experiment shows that the space around a charge or magnetic pole is not as empty as previously thought, but filled with lines of force, spreading in all directions. He called the space where these force lines exist field. Various forces are transmitted through this field. Magnetic induction line is a closed curve with direction. The outside is from N to S, and from S to N inside. To certain point, the tangent direction represents the magnetic field direction, and the density of magnetic lines of force represents the strength of the magnetic field. In the magnetic field, draw a series of closed curves with directions from the North Pole to the South Pole, and make the tangent direction at each point indicates the direction of the magnetic field at that point, which is the direction of the North Pole of the North Pole of a small compass or the force direction. Magnetic induction lines are closed curves that do not exist and intersect. Second, the tangent direction at a point indicates the direction of the magnetic field at that point. Third, the density of magnetic induction lines represents the strength of magnetic field force. The magnetic induction of a uniform magnetic field is the same in magnitude and direction. Magnetic lines of force are a set of parallel and evenly dense straight lines with the same direction, exist between two different poles and inside the electrified solenoid. Magnetic induction lines are closed curves. Outside the magnet, magnetic induction lines start from the M pole and enter the S pole. Inside the magnet, magnetic induction lines point from S pole to M pole. The distribution of several common magnetic field lines. In the magnetic field, draw series of directional closed curves starting from the North Pole and enter the South Pole, and make the tangent direction of each point on the curve consistent with the direction of the electric field. Intensity legend has it that after Qin Shi Huang unified the 6 states to enjoy himself, he built a magnificent Eiffel Palace. Since Qin Shi Huang was assassinated several times, he narrowly escaped. He was still on guard all day long, for fear of being assassinated again. So when building the Opium Palace, he ordered the craftsmen to install mechanisms on the door so that the assassins with sharp blades couldn't get in. Do you know how the ingenious craftsmen solved this problem? Their solution was install large, strong magnets on the door and fully utilized the magnetic attraction of magnets to solve this problem. Through this lesson, we have learned about magnetic fields. It is a special substance that cannot be seen or touched. Magnetic field exists around magnets. Magnetic fields exist in the space around current. After class, please think about which parts in daily life and where we can use the knowledge of magnetic field.